times 10 to the 21 cubic meter is the volume of the earth. Alright, let's now look at the concept of dimensions. All physical quantities can be expressed using their dimensions. What is the meaning of a dimension? Dimension of a physical quantity indicates the nature of the quantity measured. Now, we will represent the dimension of length by the uppercase L. So when the quantity measured is length or distance, diameter, radius, you see that? All of them are lengths. And what is the dimension of such quantities? Uppercase L. The dimension of mass we will represent by uppercase M. And the dimension of time we will represent by uppercase T. So, the three important dimensions of the fundamental quantities. What are the fundamental quantities? Length, mass, and time. The dimensions of the fundamental quantities are uppercase L, uppercase M, uppercase T. Now, let's use this to solve a simple problem. We got the equation x equal to 1/2 at squared. X is the distance that has the dimension L, is that right? T is the time that has the dimension uppercase T. This T should have been that lowercase t. This is time. And the dimension of time is uppercase T. What is the dimension of A? So, in order to find the dimension of A, all we need to do is use the dimensions of X and T and then solve for A. That's all we need to do. We replace each quantity by its dimension in that equation. So look at this. X is replaced by L, the dimension of that quantity. And T squared, time squared, is replaced by the dimension of that quantity, uppercase T squared. A, we don't know the dimension. Now tell me, what is the dimension of the number 1/2? A mere number has no dimension. So this is dimensionless. That means you can drop it from that equation altogether for this problem. So, solving for A, let's solve for A first. Solving for A, can you do that? A will be 2L divided by T squared. And we can drop 2 from here. Why? Because 2 has no dimension. And therefore, what are the dimensions of A? The dimension of A, therefore, is L divided by T squared. And this is not the standard way to write it. You see, dimensions must be written in the standard way like you write the units. So how do we write this in the standard way? It will be written LT to the power of -2. The dimensions of this quantity A is LT to the power of -2. And you will see a little later that this A stands for acceleration. The dimensions of acceleration is LT to the power of -2. In that case, let me see if anyone can do this for me. What are the dimensions of speed? Can you tell me? Send me a note if you want. Alright? What are the dimensions of speed? Okay, let's go and look at another problem. some of the physical quantities we use in this course and their dimensions in terms of L, M and T. The dimensions of length, mass and time are, I'm going to give it to you in here. Area, the symbol is A. What is the dimension of area? Area is length multiplied by length. The dimension of area is L squared. Volume is V. The dimension is L cube. Length multiplied by length multiplied by length. So the dimension of volume is L cube. Speed. Well, I asked you, is that right? I'm sure most of you got it. We represent speed by V. Its dimension is Lt to the power of -1. Distance divided by time. So the dimensions of speed is Lt to the power of -1. Acceleration, we just did it, Lt to the power of -2. Density, we generally represent density by the Greek letter rho. You got to practice that, rho. And what are the dimensions of density? Density is mass divided by volume. The dimension of density is ml to the power of -3. Okay. Let's use dimensions to solve a problem. The period of a simple pendulum is known to depend on length and acceleration due to gravity. What is a simple pendulum? Well, this is a simple pendulum, if you can see this. Now, I have a metal ball suspended by a string. I can set it into oscillation. The period means the time taken for one oscillation. Don't worry about it. We will talk about it in Physics 2. We will talk more about it. But in this problem, what does it say? The period of a pendulum is known to depend on its length and acceleration due to gravity. Well, what are you supposed to do? All right. The period of oscillation of a simple pendulum is known to depend on its length and acceleration due to gravity. Use dimensions of these quantities involved to obtain an equation for the period of a pendulum of length L. Now, this information is enough for us to obtain a mathematical equation for the period of a pendulum. Now, what are the quantities on which the period depend? We are told that the period of a pendulum depends on its length and acceleration caused by gravity. So, we will start by assuming that the period t is proportional to a to the power of y. What does a stand for? The acceleration caused by gravity. And also proportional to L to the power of x. What does L stand for? The length of the pendulum. So, we start by assuming that let the period of a pendulum be proportional to L to the power of x and a to the power of y. Okay, can you write that statement using a mathematical notation? Well, let me see if I can write that for you. We will write it like this. period t is proportional to L to the power of x, a to the power of y. Now, this is the sign we use for proportionality. And in this course, and in any other science course, when you have a proportional sign, it can be replaced by an equal sign by adding a constant. So, if t is proportional to L to the power of x, a to the power of y, I can write it as t equal to k times L to the power of x, a to the power of y. Alright, we will use this concept very often in this course. So we will start it like this. Now what you now need to do is replace each quantity by the dimensions. Now on the left side, t, the period, is the time. What is the dimension of the period t? It is t itself, uppercase t. So we don't need to do anything there. And on the right side, tell me, what is the dimension of a constant? A constant doesn't have a dimension. So we will have nothing for k. This is length L. What is the dimension of length? Well, that is L itself. We don't need to do any change there. What are the dimensions of A, the acceleration? We just did it. Is L times t to the power of -2. So, period t, the dimension is t. K, let's keep k for the time being. It has no dimension. The dimension of length is L, so L to the power of x. We replace a by its dimension. The dimension of a is Lt to the power of -2, and we raise that whole quantity to the power y. And now, use the power rule. L times t to the power of -2 all to the power of y is L to the power of y times t to the power of -2y. Okay? And in the next step, we're going to write this as, now, I did some manipulation here. You know that any quantity raised to the power of 0 is 1. So, since there is no term on the left side using L, I wrote this quantity t as L to the power of 0, t to the power of 1. Did you understand that? Well, I don't need to write L to the power of 0. L to the power of 0 is simply 1. I can as well write it as z to the power of 0, because anything to the power of 0 is 1. Now, why did I do that? Because I see an L on the right side, so on the left I introduced an L. L to the power of 0. T to the power of 1 equal to k, look at this, L to the power of x times L to the power of y is L to the power of x plus y. Okay,